This question is based on the British Mathematical Olympiad, Round 1, Question 1, 2002. We have the number 20 factorial here with 4 of its digits represented by A, B, C and D, and we have to identify these digits. We start by factorising and considering the key factors 2, 5, 9 and 11. If we consider the number 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and highest powers of 2 that go into each, 1, 2, 1, 3, 1, 2, 1, 4, 1, 2, they come to 18, therefore 2 to the power of 18 divides 20 factorial. We now consider 5, 10, 50, 20, and highest power of 5 goes into each of those, and 5 power of 4 divides 20 factorial, so that 2 to the power of 4 times 5 to the power of 4 times 2 to the power of 14 divides 20 factorial. We look at these two here. We find that 2 times 5 to the power of 4, which is 10 to the power of 4, divides 20 factorial. So 10,000 divides 20 factorial, which means that the last 4 digits are all 0, which means that B equals 0. So we now consider our number 243, 2, 9, C, D, 00817, 6, 6, A, and the others are zeros. Now, 2 to the power of 14 divides this number. We've got, as it were, 14 2's left over. And this means that the first digits up until A represent a number which divided by 2 to the power of 14 and which can therefore be divided by 2 to the power of 3, which is 8. And if 8 divides a number, it must divide the last 3 digits of that number. So we now know that divides 660A. If we consider the fact that 8 divides 640, 648, 656, 664, adding 8 each time. 8 divides 164, so E equals 4. So our number has become 24329 CD 00817 664000, and 9 is less than 20, therefore 9 divides 20 factorial, and if 9 divides a number, the digital root of that number must be 9. So we come along here, 2 plus 4 plus 3 plus 2 plus 9, 6 plus 3 is 9, plus 9, that leaves the 2. And the rest of it, 8 plus 1, which is 9, 7 plus 6, which is 13, plus 6 plus 4, that is 23, so 2 plus C plus D plus 2 plus 3 equals 9, so that 2 plus 5 plus C plus D equals 9, so that 7 plus C plus D equals 9, so that C plus D equals 2. And now we consider divisibility by 11. Now to check for divisibility by 11, for example, in the number 1331, we add the digits together with alternating signs. Plus 1 minus 3, plus 3 minus 3, minus 1, that equals 0. And if 11 divides that number, then 11 divides the number we started with, and 11 certainly divides 0. So we look here, we have 2 minus 4 plus 3 minus 2 plus 9 minus C plus D minus 0 plus 0 minus 8 plus 1 minus 7 plus 6 minus 6 plus 4, and the rest is 0. And so I've completed the sum now, and we have 8 minus C plus D minus 10 equals 0 or 11, so that D minus C minus 2 equals 0 or 11. It must be a multiple of 11. It can't be 11, so it must be 0. So D minus C equals 2. And from our previous sum, D plus C equals 2. So we add these two together. Pardon me. We add these two together. And we get 2D equals 4. So D equals 2. And D plus C equals 2, which means that C equals 0. And so our final summary of answers: A equals 2, B equals 0, C equals 0, and D equals 2.